Good. It's good that you caught that. You can't forget this bond over here. So it's good that you saw that you caught yourself here and put in this double bond. This is a stereocenter, so technically there should be two different products on the wedge and on the dash. But I'm not going to bother drawing that. By the way, since we have to do two different paths here, it's useful to use an identity symbol here to show we could just have the bromine attacking this carbocation, or I'm just going to redraw this picture so that I can use it for resonance. So an identity symbol shows this is not a reaction, just a redrawing. And then it's important here that you put in a resonance arrow, because this was a resonance step, not a reaction step. That would have been this step here. So this arrow should be a resonance arrow. So this arrow here that I'm pointing to. Yeah.
And then I shouldn't attack till first.
That's fine. Now this is a reaction. So here we use a reaction arrow. All right. Now actually I really screwed this problem up, but we'll see why in a second. Now, would you have called this the 1-2 or the 1-4 addition?
That would have been a 1-2 addition.
Yeah, in order to keep that in mind, it helps to keep drawing the hydrogen. Here's the hydrogen. Well, we call this a 1-2 addition. And how about then down here? Would this be the 1-2 or the 1-4?
It'd be the 1-4.
Right. However, I screwed this up because the 1-2 product is the same as the 1-4 product here. If you think about it, if you don't draw in the hidden hydrogen, that's clear.
Sure.
This is a cyclohexene with a bromine adjacent to the double bond, and this is a cyclohexene with a bromine adjacent to the double bond. We could simply rotate this or flip this so that you can see these are both the same picture. So actually the 1-4 product here is the same as the 1-2 product. So we got more practice with the mechanism, but after you go through the whole mechanism here, you would actually say you'd only want to present one of these. You would say that in this case there's actually only one product. So I guess the lesson here is even with the conjugated system, sometimes the 1-2 product is identical to the 1-4 product, and then you still only get one. So we got more practice with the whole mechanism here, but this wasn't really the best example I could have picked for 1-2 and 1-4 because they both ended up giving molecules which were identical to each other. So these are really the same thing. So you'd only want to draw one of those. Try question 8 here if you were assigned. 28. So here they told us that we're reacting 2-methyl-1,3-butadiene with hydrochloric acid, and they told us that they want the major 1-2 addition product. They want the major product from 1-2 addition.
You know, I'm not familiar with this nomenclature. I always thought if it's going to be, does this mean that it's a methyl on the number 1 carbon?
That's, oh, well, I think you missed this number over here.
Oh, okay. There we go. 2-methyl.
That's right. let's talk about what we've got so far. Now you did figure out the structure here. This but means 4 carbons. But means 4 carbons, and diene means there's 2 alkene groups, starting on the number 1 and the number 3. So here's 1,3-butadiene, and then there was a 2-methyl group. So you figured that out. Now, what you have drawn is this. You have this double bond attacking the hydrogen. But it's also possible that this double bond could attack the hydrogen. They want the major product. So which of those?
I was going to go through and work both of them.
Okay. All right. Well, all right. That wouldn't be a terrible approach. Maybe to save time, let's talk that out in words a little bit more. So which would be preferable, to have the left-hand double bond attack or the right-hand double bond attack?
It's going to be preferable to have the left hand because you have a more substituted number 2 carbon.
Yeah, we'd like to form the most substituted carbocation. Well, if we attack here, we're only going to get a secondary carbocation. But if we use this double bond, we can get the tertiary carbocation. So to form the major product here, we'll use that left-hand carbon. By the way, again, we're forming a stereocenter. So technically there should be 2 products, one in a wedge and one in a dash. But I'm going to continue not drawing those because I still don't think that's too important in this chapter. But you can see on the exam whether that seems to be important.